All right. Welcome, YouTubers. This is part 2 of my video, and I'm actually going to start my Facebook Live video right through the eyepiece here. Good morning, Facebook fans and friends. This is your friendly neighborhood astronomer, and this is the November 8th, Election Day Lunar Eclipse. We are into totality now. The moon has moved into the umbra, or the darker part of the Earth's shadow. It's an awesome spectacle in the sky right now. We have the beautiful winter sky constellations out, Orion and Taurus and Mars, and there's even going to be an International Space Station pass. If you can see this on the YouTube video, I'm pointing at the eclipsed moon. I hope it shows up well on camera. It's showing up pretty well in the telescope. The YouTube camera, let's see, I'm not sure how well it'll allow me to just move and point out the sky, but if the laser is visible, I'm pointing out the constellations Orion and Canis Major and Taurus the Bull. So in Orion here we have Betelgeuse, Bellatrix, Rigel, Sath. Then Alnitak, Alnilam, and Mintaka are the main bright stars that we can see in Orion. And of course the Orion Nebula in the dagger or the sword that hangs down below his belt. The Orion Nebula is the middle part. We have an airplane trail running right through that now. It's a little bit reminiscent of the Milky Way, the cloud of the Milky Way, however, not as cool because we're not in dark sky. And of course, the winter hexagon or winter circle made up of the Gemini stars, Castor and Pollux, and Procyon, Sirius, and Rigel, and Aldebaran in Taurus, and Capella and Auriga make up a nice, very nice winter circle or winter octagon. And Mars is kind of punctuating that right in there. It's almost one of the horns of the bull. I don't know if you could see my laser throughout all of that, but if you're out and you're looking up, that is a lot of what we're looking at right now. Let me go ahead and take another quick look at where this video is aligned. It looks like it's getting me pretty well. I don't know how well it got the sky, but hey, it is what it is. So let us hope that everybody out there in Facebook land is enjoying this beautiful lunar eclipse. Lunar eclipse happen fairly frequently, at least, once every, I'd say, 18 months or so, sometimes more frequently. And they're followed usually by solar eclipses somewhere, at least a partial somewhere on our globe. And again, globe. So sorry, flat earthers, the earth isn't flat. It is an oblate spheroid. Why is it an oblate spheroid? Because it's spinning. It's not just a sphere made round by its own gravitational pull, but it is oblate because it spins so quickly that it flattens out a little bit. That's why it bulges at the equator. Oh yes, the wonders of physics and celestial geometry. Anyway, I hope you're out and enjoying this beautiful sky. If not, and you're sleeping, that's fine. You can watch the videos later. It is a fairly quiet night here in my neighborhood in Westchester. I'm just out on my front lawn where I have a good view of the moon. I wasn't going to get up this early, but I just couldn't sleep. I mean, it's fun, it's exciting, and hey, I'll catch some Z's later. In any case, I have some friends who are out, probably at Harrison Park. Joe Guzman, the Chicago astronomer, who was on Chicago Tonight, earlier tonight, with Geza Juk from the Adler. And so Joe and Geza gave us a nice explanation, or gave a nice explanation to Paris about what a lunar eclipse is and how to view it. Really, you don't need anything. Just go out and look. And right now, the moon is almost completely red. So the redness, as I was explaining on my earlier YouTube video, the redness is caused by the sun's light being lensed or refracted by the Earth's atmosphere. The red light doesn't scatter as much, so it gets bent and kind of focused onto the moon, versus the blue light, which gets scattered. Now that blue light scattering is what gives us our blue sky during the day. The red light being lensed is what gives us our red skies in the morning and the evening. So all around the Earth, picture the sunlight coming from one direction and hitting the Earth, and all around the globe there's this circle of sunrises and sunsets, and the red light from all those sunrises and sunsets, that sun's red light, is being focused onto the moon, turning it red. Now what's in between, or what's in the atmosphere, determines how red the moon will get. So particulate in the atmosphere, pollution, abundances of various gases, forest fire and volcanic debris, things like that, those all contribute, and the moon's distance. So sometimes there's a super moon, a super full moon, where the moon is closer to the Earth, that is perigee, and sometimes there's a full moon when the moon is further away from the Earth, or when it's at its farthest point away. That's called apogee. So, in any case, all those things contribute to exactly what a lunar eclipse cone looks like. We're just very fortunate that there are no clouds. I can tell you that the first several, and I mean several, lunar eclipses that I tried to view, even when my son was a young boy, and we would go down to the Adler, or even when I was volunteering at the Adler, we would get clouded out almost all the time. I remember groups of us with our telescopes chomping at the bit, waiting to go outside, and sometimes it would be snowing sideways, and we would wait for little sucker holes, and when they would happen, sometimes at 3 or 4 in the morning, we'd rush out with the telescopes, and we'd point at the lunar eclipse and show the onlookers, the intrepid fans who joined us, some little view of the eclipse, and we were just happy to be able to do that. But so many times it was clouded out. I remember the very first good lunar eclipse where I didn't get clouded out, and we had clear skies, and it was at a decent time of the night. It was 2004. It was Game 4 of the World Series. Boston swept, who was it? Now I forgot. Was it the Phillies? No. Anyway, I was just talking about this with my friend Peter Marzano. But anyway, Boston broke their 86-year drought. They won the World Series, and there was a lunar eclipse happening right at that time. I was actually volunteering through Adler out in Hinsdale at the Hinsdale Library, and we had a nice group of people there, and I got to see really my first full and clear lunar eclipse. Tonight, I think it's just beautiful. Hey Liz, good morning. Sharon, good morning. Thank you for joining me, and I hope we're able to get out and look at this beautiful lunar eclipse with me. So in any case, lunar eclipses last for a long time. So the totality, or the time that the moon spends in the umbra, or the darker part of the Earth's shadow, is a very, very long time compared to a solar eclipse, which lasts on the order of minutes and seconds. By the way, the next great solar eclipse happening for us here in the United States is going to be April 8th, 2024. It's Monday. The eclipse happens around between 1 and 1:30, I think almost right at 1:30 p.m. Central Time anyway. So make sure you're going to get yourself to that path of totality, and make sure the weather's clear. Do whatever you have to do. Build a weather machine. Seeing the sun's corona is a moving experience. That's why there is such a thing called eclipse chasers. There are some people who have the means, good for them, to chase eclipses all over the globe wherever they happen. And many people have viewed many solar eclipses, many of those total solar eclipses, some of them annular eclipses, or probably even partial solar eclipses. But if they can get to the path of totality, they do it, because the path of totality is where so much more of the magic happens. When it's a total eclipse, you see the solar corona, and you see solar prominences naked eye. Oh, it's fantastic. And when it's an annular eclipse, you see that ring of fire, so the moon doesn't completely cover the sun's disk. And you don't get to see the solar corona, but you do get to see a bright ring of sunlight with the moon blocking out very little. So anyway, eclipses are cool, and they're historically cool. Edmund Halley refined using Newtonian mechanics, and he was one of Newton's few, if only, friends. Newton wasn't an easy guy to get along with, but he was brilliant. Anyway, Edmund Halley used Newtonian mechanics to predict eclipses. I believe he mostly predicted, or only predicted, solar eclipses, but he even did crowdsourcing experiments to give people in England to report back as to what time of day, what exact time the eclipse happened for them, and what part of, let's say you're in one part of London and somebody else is in another part of London, and where that eclipse line was. He predicted eclipses to within a couple of minutes. I mean, it was just a phenomenal achievement of human brain power and mind power, and just the simple fact that he could understand Newtonian mechanics, where he was probably one of the few people in the day who really could grasp Newton's ideas, and not only grasp them, but put them to work. Edmund Halley is undersung, in my opinion, and he is not just famous for predicting the return of the comet that bears his name, but he is also famous for so many other wonderful things. He was a wonderful cartographer, and just a brilliant guy, all in all. Selfless guy, generous guy. I can go on and on, but I won't, because it's all about the lunar eclipse tonight. In fact, I think I'm going to end my YouTube video right now and thank everyone for joining me on YouTube. And then we're going to take a little tour around through the telescope on Facebook Live. So YouTubers, this is your friendly neighborhood astronomer signing off. Enjoy that lunar eclipse. We'll give you one last shot of it, and have a great night.